Now today I take some important integral function of this. So now the first question is prove that integration of tan x dx that's equals to 6 log of sec x plus c. And now we have that integration of tan x dx that equals to, and now tan x equals to, we know also sin x by cosine of x. So integrating function of sin x by cosine of x. So that's not as the dx is coming, so dx I also write that. That's it. And now that's because we taking the minus and minus function, so minus of integrating of minus sin x by cosine of x of dx. That's it. And that's it. And the minus and minus functions coming from, you also know, from the last function. So now as we know that, as we also know that integrating function, you can also say that derivative. So now derivative of sin x, that's equals to, we know, cos x. So here we have no plus minus function, so also plus and plus function is coming. And now but if derivative of sin x, then also we coming that the minus of sin x. That's it. Yeah, this minus is important, so also we can write that minus of integrating function of d of cos x by cos x. You know also it's a very normal function of this. So now we know that integration of dx by x, that's equal to how much? It's very easy, as log x, and this class of c. That's it. Also watch my previous videos, all that links you can find that the I button, or you also find that in the last answer. So now minus of log of cos x plus c, that's it. So it's the proof. But our question is sec x, but here coming that the cos x, also that is plus log, and here the minus log is coming. So now I also transform the minus. So now log of cos x to the power minus 1 plus c. That's it. That's a very easy function. So now we know that cos x to the power minus 1, that's equals to, we also write that 1 by cos x. That's it. That's very easy. As well, if a to the power minus 2, that's equals to 1 by a to the power 2. That cos square is coming, and also we know 1 by cos x equals to how much. So now log of 1 by cos x plus c. That's it. And now we also write it, the 1 by cos x, that's equals to sec x. That's very easy. So now log of sec x plus c, and its answer, and also prove the question. So now that's the very easy function, easy part. So I also write the question. So now integrating function of tan x times of dx, that's equals to log of sec x plus c, and it's the answer also. And also it's the proof of the first part. I also write that by my red pen, and it's very easy function, and this coming from this, the log of dx and d of the function of x, as here x equals to cos x, that's cos 1, and sin x derivative also is cos x, and as we know that the sin x equals to cos x, but cos x derivative is minus sin x. That's minus is coming from the minus is also given. So now minus and minus is cancelled of plus, so the previous line is coming, and we also this function also now. So that the integrating function of cot x dx, that's equals to log of sin x plus c. That's it. And we have integration of cot x dx, that's equals to, we also write it the previous vector, that is, we know that cot x equals to, we also write that, sorry, not this, so cos x by sin x as well, tan x equal to, also we know that the sin x by cos x. So now integrating function of cos x by sin x, that of dx, that's it. And also we have that, and also we know the function of this. So now differentiation, or you can also derivative of sin x, that's equals to cos x. It's very easy. So this cos for, we don't use the minus minus factor, so also we can write it easily, d of sin x by sin x, that's very easy term. So it's not like even dx, so d of sin x is coming. So now again we know, that integration of dx by x, that's equals to log of x plus c. That calls for here also log of sin x plus also this x, and this x is coming, so that's a plus c. That's it, and that's the easy function. So now also we know, yes, that's of integrating factor of cot x dx, that's equals to, also we write that the answer is also sin x, log of sin x plus c, and it's also proof, and it's also answer. And what might be from the description. And now the first step is very easy function of this cot x dx, that's it. And also the it's easy method, it's easy than the tan x. And now the integrating factor of sec x dx, that's equals to log of sec x plus tan x plus c, and that's equals to log of tan of pi by 4 plus x by 2 plus c. And now we given that integrating factor of sec x dx, that's equals to, also it's very important and very easy, interesting, and others way of this mathematics, and this answer approved the formula. So now also I write that the sec x, so sec x plus tan x we need also in denominator. So now also we write the, from this question is that numerator is sec x, and the numerator also, that is sec x plus tan x of dx as well. Sec x plus tan x and sec x plus tan x is cancelled out, therefore the sec x coming, that's called for. So now sec x plus tan x, and the numerator is also sec square x plus sec x times of tan x of dx, that's this. And now also we know that the sec x plus tan x, that's equals to how much? So yes, we know that the integrating function as well, sec x and tan x is different sides. So now we know that differentiation, or you can also say the derivative of sec x, that's equals to, also we know that it's very important and easy. So sec x times of tan x dx of dx also, that's it. And now differentiation of tan x, I also write the tan x, that's equals to tan x derivative is also, we know, the sec square x of dx, that's it. And this the coming, and this also the coming from this method, the sec x tan x and the sec square x, that's very easy and important and interesting also. So now integration of sec x plus tan x, and the numerator I also write that d of sec x plus tan x also, that's equals to, also we know the integrating function of dx by x, that's equals to log of x plus c also. And while we use the mod, I also find that the previous videos also watch that. And now log of sec x plus tan x plus c, that's the proof, and it's very easy method of this. It's the number 1 is proved also. It's very important and easy method. And now sec x by tan x I also use for this the second proof for use. Also watch this video. So now also the sec x plus tan x that's equals to, also we know the sec x is coming the 1 by cos x plus of tan x is coming that the sin x by cos x, that's it. And now the denominator is coming, so now 1 plus sin x by cos x is coming the fiction of this. So now I use this method for the last line. So 1 plus sin x by cos x, that's it, and use the higher mathematics algebra function. So now we know that 1 equals to, I write it by black pen. So now 1 equals to, I also write that the sin square x plus cos square x, that's I write that. And now sin x equals to, I also write it again, it's the I find the number 1. And now sin x equals to, I also write that the 2 times of sin x, sorry, is 2 times of sin of x by 2 times of cos of x by 2 is the second. And now cos x equals to, I also write that the cos square x by 2 minus of sin square x by 2 and is number by 3. So now I write here the 1 2 3. So now sin square x by 2 plus cos square x by 2, that is 1. And now plus of 2 times of sin of x by 2, sorry, sin of x by 2 times of cos of x by 2, that's it. And the denominator is cos x, that's equals to cos square x by 2 minus of sin square x by 2. So that's it. And now that's equals to also from this function. So now a square, sorry, a plus b whole square, that's equals to a square plus 2ab plus b square. And the sin square x by 2 is a square and the cos square x by 2 is the b square. So now sin of x by 2 plus cos of x by 2, that's whole square. And the denominator is cos square x by 2 minus of sin square x by 2, that's it. That's very easy function. So now the cos x and here the sin x is coming, so I also write it the a plus b equals to b plus a is symmetric and reflexive method. As well we have the plus in the algebraic function. So now I also write it cos x by 2 plus sin x by 2, that's of whole square. And the denominator is also a square minus b square, that's equal to, we know also the classical algebra from the a plus b times of a minus b in our childhood, we know it. So now cos of x by 2 plus of sin of x by 2, that's time of cos of x by 2 minus of sin of x by 2, that's it. And now the cancel out is cos of x by 2 plus sin of x by 2. So now we have the function also cos of x by 2 plus sin of x by 2, that's by of cos of x by 2 plus, sorry, that's not plus, that's minus of sin of x by 2. And now I also find it by my red pen. So now dividing both side, sorry, both side not, the numerator and denominator is by the cos x, sorry, it's not cos x, it also be cos of x by 2, and the 1 plus tan of x by 2, and the denominator is 1 minus tan of x by 2, that's it. And now we know that function is the sine of theta by cos of theta, that's equals to tan of theta, that's it. That's very easy in your childhood. So now 1 plus tan is 1 is also, we write it the tan of pi by 4 plus tan of x by 2, and the denominator is 1 minus tan of pi by 4 times of tan of x by 2. That's it. And now 1 equals to also tan of x by 4 also. Sorry, x by 4 is not, pi by 4 also that. Now sec x plus tan x, that's equals to also from this method. So now tan of pi by 4 plus tan of x by 2, and the denominator is 1 minus tan of pi by 4 times of tan of x by 2. That's it. And now that's equals to tan of pi by 4 plus x by 2. This is the simple method of this. I also write the denominator is also in my rap. So now we know that the tan of a plus tan of b by 1 minus tan of a plus b, sorry, 1 minus tan of a times of tan b, that's equals to tan of a plus b. We know this function also of this method. So now integrating factor of sec x of dx, that's equals to log of sec x plus tan x plus c, that's it. And that's equals to log of also sec x tan x is coming. So now tan of pi by 4 plus x by 2, and that's plus of c. And I also review the why we use the log of this mod function, and that's it. And that's the interesting function, and this the second proof of this function, and from this is very interesting. It's also you can read it your 7, 8, 9 or 11 class algebraic function. And the fourth question is now so that the iterating function of sec x dx, that's equals to log of sec x minus cot x plus c, and the second is that's equals to log of tan x by 2 plus c. And now we have from this question, so I write that this. So now integrating factor of cosec x dx, that's equals to also we write this the previous this previous formula. So now that is cosec x times of, so now I also write it as well. So now by my black pen, so cosec x minus of cot x of dx, and also the denominator is also cosec x minus cot x, that's it. And this is the very important and interesting formula is coming for this inverted geometric function as well, cosec x minus cot x. So this equals to cosec square x minus cosec x cot x of dx, also dx, and the denominator is also as well. So now cosec x minus of cot x, that's it. That's very important and easy function. So I also write it well why it's coming from this formula. So we know that the differentiation of, so now differentiation of cosec x equals to minus of cosec x times of cot x of dx. Also cc function is coming, so therefore the minus is coming. And now differentiation of this main function cot x, that's equals to also we know that function is cot x equals to how much, so minus and minus function is minus coming. And now that's equals to very important, so the first function is coming, so minus of cosec square x of x, that's it. And that's equals to also minus and minus of cosec x cot x and cosec square x. So I also write it cosec x minus cot x, that's of the numerator, and the denominator is cosec x minus cot x is coming the denominator. So now that's equals to log of cosec x minus cot x is coming and plus c, and it's the answer. As well, we know that the dx by x of integrating function is log of x plus c, and it's the rough method. So now I also find this the first formula of this, so I also write it the proved, and it's remarked that the and also answer a question, and it's the first question formula is used. So thank you for watching this, and now the second method is coming. So now cosec x minus of cot x, that's equals to 1 by sin x minus of cos x by sin x, that's it, and that's equals to the denominator is sin x and the numerator is 1 minus cos x, that's it. And now the previous formulas. So now 1 equals to, I can write this the watch this. So now sin square x by 2 plus cos square x by 2, that's it. And now cos x equals to cos square x by 2 minus of sin square x by 2, that's it. And now the sin x equals to, this is the 2 times of sin of x by 2 into cos of x by 2, that's it. And now the sin square x by 2 plus cos square x by 2 is coming, so 1 is 4, and the minus of cos x is minus of the bracket I also given this, so cos square x by 2 minus of sin square x by 2, that's it. And the denominator is sin x, that's equals to, I also write it 2 times of sin of x by 2 times of cos of x by 2, that's it. So now I also write it from this question, that's is the function of sin square x by 2, sorry, I also remove that. So now I also write it sin square x by 2 type plus of cos of x by 2 and minus of cos square x by 2, and this the minus and minus is coming plus, so that's equals to sin square x by 2, sorry, I remove it also, so sin square x by 2, that's it. And the denominator is 2 times of sin of x by 2 times of cos of x by 2, and that's equals to, also this function is coming from this, so cosec x minus cot x also. And now that's equals to cos square x by 2 and cos square x by 2 is cancelled out as plus and minus function, so now the 2 times of sin square x by 2, and the denominator is 2 times of sin of x by 2 into cos of x by 2, that's it. And the cancel out is 2 and 2, and the sin of x by 2 and sin of x by 2, and that's equals to sin of x by 2 by the denominator is cos of x by 2, that's equals to also sin of x by 2 and cos of x by 2, that's equals to, I also write it as we know that in, I also wrap that here the sin x by cos x, that's equals to tan of x, that's it. And that's equals to, also the x is becoming x by 2, so tan of x by 2, that's the function as the common fixed function. Sin of x by 2 by cos of x by 2 equals to tan of x by 2, so therefore I also write it given the fixed function as the integrating function of cosec x times of dx, that's equals to log of cosec x minus of cot x of plus, and now that's equals to log of, this is the function is tan of x by 2 plus c, that's it. And it's the proof for this question, and it's the second, and it's the proved of the first function. And that's it. Thank you for watching my video. Like, comment, share, subscribe my YouTube channel, and even press the bell icon. And also it's the very interesting, important, and very hard method of this. Is the very qualified is the function is coming, and the second is very important for your exam. And now I also write the some important function of this. So integration of f naught of x by f of x of dx, that's equals to also log of f of x of plus c, that's it. As we also know that the dx by x equals to log of x plus c, that's it. So now the function is also, the second is, if also the first is the f of x derivative is f naught of x, so now the second is integration function of e to the power x times of f of x plus f naught of x, that's equals to e to the power x times of f of x plus c, that's it. And now that's equals to also the if e to the power x times of f of x plus c, that's equals to also this function. Also this I taking from this the z, so e to the power e to the power x times of f of x plus c, that's equals to z, and the derivative of x, that's it. E to the power x wholes of f of x plus of f of x derivative is also e to the power x, that's it. The e to the power x times of f naught of x is coming as well. The f of x derivative is f naught of x, and also the c is coming 0, and that's equals to also dx, as the x derivative is dx and the z derivative is dz, that's equals to dz. This was phosphor coming this. And now e to the power x and e to the power x I take common of these two functions. So now e to the power x times of f of x plus f naught of x, that's it, of dx, that's equals to also we know the dz is coming, that's it. But the dx also I forget that writing there. So f of x and f of x and e to the power x, and this e to the power x is coming here. So now I also write that the dx and dz is cancelled out, so now the integrating factor of the both side by x and z, so now that's equals to integration of e to the power x times of f of x, and this the plus of f naught of x of dx, that's equals to also dz. So now integrating factor of dz, the integrating factor of dz, that's equals to z also coming. So that calls for the question is coming. And also we know that we also know that z equals to e to the power x times of f of x plus c, that's possible. So this question is qualified. So this the formula is proved also. So now the third method is integration of f of x to the power a times of f naught of x of dx, that's equals to also we know that the f of x to the power n is taking u x, and the f naught of x taking the dx also. So that's equals to 1 by n minus 1 times of f of x to the power n plus 1 plus c, that's it. As the f of x times of f naught of x is the derivative function of the f of x. Here also a not equals to minus of 1. Also the if the n is minus 1 and that's plus 1, so 1 by 0 of something is also infinite series. As well, we know that the integrating function of x to the power n of dx, that's equals to x to the power n plus 1 by n plus 1 plus c, and this is formula is the proof that thank you for watching this video, and like, comment, share, and subscribe my YouTube channel. Never miss, press the bell icon as well. You miss the also my taking the videos, and also follow me on this, that's my social media Twitter account. Bye bye, have a good day.